Hey guys, here with another example of completing the square this time. It will be a slightly more complicated example. So here we have a function, a quadratic function. Again, we know it's quadratic because we have, for the highest degree term, an x squared. So it's quadratic. And we have something slightly different in this problem than the last one. We have a coefficient on x squared that is not a 1. So in the previous video, it was just x squared. Well, if it's just x squared, then the coefficient is implied that there's a 1 there. Now, completing the square only technically works if this number is a 1. That doesn't mean you can't do completing the square on something like this, though. You just have to do one extra important step, and that is factor out the coefficient on x squared. But of course, when you factor it out, you have to factor it out from every term. So, step 1. Factor out that number. So what that means is pull out the 4 and put parentheses around everything else. Okay? And if you're not sure how to factor out, what you actually do when you factor out a number from a quadratic or any polynomial is you're dividing every term by the number you're factoring out, and whatever the result is of that division, that's your new coefficient. So for the first term, 4 divided by 4 is just 1. And so we have 1x squared. We don't bother with the 1. We just say it's there. Negative 12 divided by 4 is negative 3. And then we have our x. Negative 1 divided by 4 is negative 1 over 4. So that's the first step you have to do when you have a coefficient on x squared that's not a 1. From there, you do the normal completing the square method that we went over in the last video on what's in parentheses. However, there is one slight step you have to do at the very end, which is once you've done the completing square, you're going to want to distribute this coefficient that you've factored out in the beginning. You're going to want to distribute that back in. Let's see what that looks like. Okay, we're going to first focus on completing the square on the quadratic inside parentheses. Remember, we identify the cross term, or the term which has x to the first power. In this case, it's this guy. We look at the coefficient. Now, the coefficient here is not just 3, it's negative 3. Keep in mind that sign in front of it matters. So we take the negative 3 and we divide it by 2. Always divide by 2. Then we take that entire thing and we square it. Now, this isn't a video about how to apply exponents to things like these. So I have a video on that under exponent properties if you need to review. But basically, this just means do negative 3 halves times negative 3 halves. Another way to think about it is you just kind of square both the numerator and denominator separately. So negative 3 all squared gives you positive 9. 2 squared is 4. This is what I call the special term. I don't think anyone else calls it that. That's just something I call it. Now, if you remember what we did last time, we have to add in the special term and then remove it, take it away. But we're only doing that inside parentheses. So we have our 4 out front. We have our x squared. We have our negative 3x. None of that goes away. We have our negative 1/4, which I'll write out here. Leave us some space for our special term. Okay, special term, I'll put that in yellow. So we're going to add in 9 over 4. And to account for the fact that we're adding in a number, which would change what this equation actually equals if all we did was add it, we're going to take it away so that we're technically changing nothing. In other words, this is, for lack of a better word, legal to do that since we're not really changing anything. What we're going to want to do is put parentheses around the quadratic part. Remember, we start in front of x squared. We end right there after the special term that we add in. And then the special term that we subtract out does not get included in parentheses. Next, we need to condense this guy down. Remember what I said in the previous video, how you do that. You do, well, first let's write what's out here. So we've got 4 on the outside. We've got x squared. No, sorry, we're condensing it. So it's going to be an x plus or minus something. And then that entire thing gets squared. Now what goes here? Well, you take this let's say this coefficient here, and divide it by 2. That's the number that goes right here. If you take -3, divide by 2, that's what you put. So -3 divided by 2 is just -3/2. Another way to think about it is it's always just going to be this number here that you put in parentheses when you're trying to calculate the special term. You don't put the result when you square it. You put just that number there. Okay, we've got this part condensed down. We need to simplify this part. So we've got -9/4 minus 1/4. Thankfully, right, we've got common denominators. If we didn't, we'd have to make common denominators. In this case, it's a bit easier. All we have to do now is essentially do minus, it's going to be over 4, and this is going to be 9, well, let me say it this way actually. This is -9 minus 1 up top. So -9 minus 1 is 10, or -10, but I have the negative out front. So either we could have written this as plus -10. I'm just simplifying it, saying minus 10 over 4. Now, we want to simplify this a bit. A couple things. The 4 needs to be distributed back in, as I said. Also, if you have a fraction that can be reduced, you need to reduce it. And we have 10 and 4, both even numbers. That means they're divisible by 2. We should factor out a 2 from both, or cancel out a 2 from both. If you divide 10 by 2, you get a 5. If you divide 4 by 2, you get a 2. Okay, next, distribute in the 4. So this 4 is going to be multiplied by this first term here, this whole thing we could think of as a term. And the 4 gets multiplied by the fraction here. So we drop the outer parentheses and we get 4 times x minus 3/2 squared. Minus, okay, when I distribute the 4 in, it's going to be a 4 over 1. I guess I'll write it out. 4 over 1 times 5 over 2. You can cross cancel. I mean, you could multiply the 4 and the 5 and then reduce. I don't like to do that. I like to avoid multiplying and making big numbers when I don't need to. I always look for the cross cancellation. I recommend you do too. So 4 and 2 share a common factor of 2. We can just divide out a 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Now we just have 2 times 5 is 10. So the final answer is going to be 4 times x minus 3/2 squared minus 10. And we are done. This is the above function we started with, but it's been rewritten using completing the square. Why would we do that? Well, a few reasons. Sometimes it's not y equals all this. Sometimes it's an actual number. Maybe it's 0. And if it is 0 and you want to solve for what x makes this happen, it's actually pretty easy to solve once you've got it in this form. Not so easy to solve when you start out like this. Like if this was equal to 0, it'd be kind of hard to solve it with those with the quadratic written that way. Another reason why you might want to do this is sometimes you want to graph the quadratic, and it turns out when it's written in this form, which is called the vertex form, maybe that's worth noting. So completing the square actually gives you the quadratic equation in vertex form. It's really easy to graph when it's in vertex form. It turns out that this number here is actually the x coordinate of your vertex. Sometimes we call it h. And this number out here is the y coordinate of the vertex k. And so it gives you h comma k really easily because it's staring right at you. So that's why you may want to use completing the square on something like this. And again, this is how you do completing the square when you have a coefficient on the x squared that's not, it's any number other than 1. Great, thanks for watching, and I will do maybe another video of maybe an even harder completing the square problem. Thanks.